So today we have the problem 21 from Spring AMC 12b, which is the S be the sum of all positive real numbers x, for which x to the square root 2's power is equal to square root 2 times 2 to the x power. So which of the following statement is true for the solution, for the sum of the solutions? So first, obviously, we can see that when x is equal to square root of 2, then the statement is true. This is pretty obvious since we have square root is equal to so this is pretty obvious, right? Well, now, is this the only solution, or is there like any other? Or is there any other solutions? So we can try to simplify it a little bit by taking logarithms. So if we take log 2, well, actually, I'm probably going to take log square root of 2. This might be easier. Log gives 2 root 2 log. Actually, I'm probably going to just do log base 2. Log base 2 x is equal to 2x. Well, 1/2 comes from a log base 2 root 2. So now we can try to move one thing to the other side. So move everything to the right side, then we get log base 2x is equal to 2 to the x minus 1 minus 2. So now we cannot really proceed it algebraically, but we can actually try to graph it out. So we know that one of the intersection is square root of 2, and before that, which of it is larger? So we can see that if you have 2 to the x minus 1 minus root 2, then you basically multiply it by 2 to the negative 1 plus root 2, which is obviously less than 1. So the thing is steeper, right? And you also have you also have the log base 2. So when x is equal to root 2, then you have 1/2. And how about around x? So how about if we have around x? And this will involve some derivative thing, which you'll probably learn it in calculus. So now log base 2x increases slower, so the first intersection before the first intersection, the log base 2x is above, right? And that should be actually, yeah, this can be proven. So log base, so when x is equal to 1, then you're going to have 0 and, yeah, before 1, I mean. So how do you determine the other intersection? Like the approximate value, and that should be fine. So if we can graph both out, yeah, what if one x is a little bit less than square root of 2? Yeah, before the intersection, we can see that the right-hand side, before the first intersection, right-hand side is actually greater than left side. And this can be proven by the derivatives, since when they're equal to 1, it's the same, and the derivative is keep like, so the second one is the second one is less. So the second one, the derivative is smaller, which basically means it's increasing less steeper. So they'll have the first intersection, and they will also have the second intersection because the exponential one should increasing faster. So we can take the derivative of both sides. So the first side the left side we caught y is equal to log base 2x. Then take learn is equal to y is equal to log base 2x, and log base 2x. So, and take the derivative, we get dy over dx is equal to y. The derivative of learn of log base 2x is 1 over log base 2x times wait. Multiply the y to the other side, y times the derivative of log base 2x. So log base 2x is a constant, so basically we have learn of log base 2x. Wait, no, this should go as the other way. So if we have y is equal to log base 2x, then we basically have 2 to the y is equal to x. And then we take dy over dx. Now we take learn both sides. So y learn 2 is equal to learn x. And then for this one, we actually take with respect to y. is equal to dx over dy. Then we have dy over dx we desired. The derivative of y with respect to x is just equal to 1 over x ln 2 in this case. So you multiply by x to the other side, and then you flip it. Okay, so and the right side is you have a to the x power. So a to the x power I think we proved it before is a to the x times ln of a. The right hand side we have b over dx of 2 to the x 1 minus square root of 2 is basically just equal to 2 to the x power times ln of 2. Entire thing divided by 2 to 1 plus square root of 2's power. I'm missing a column. I'm missing a parentheses. Okay, so we want to compare these two. When x is equal to square root of 2, then ln of 2 is approximately like 1/2 is greater. No, it's greater than 1/2. So if we compare it when x is equal to the square root of 2, then the first one is less than 1. And the second one, I think the second one cancels out, still less than 1, but the first one is way less than 1. So the first one is less than the second one. So basically we know that there are two intersections which they'll always intersect again. So the second intersection, we just have to approximate it. Approximate the second intersection. The second intersection gives us that it should be between 3 and 4. So if x is equal to 4, then we have the left side be 2, but the right side be 2 to the 3 minus square root of 2, which is way greater, which is greater than 2, obviously. So, and also it's increasing greater as we proved, so therefore it must be less than 4. So basically we have the second intersection be less than 4. But since by the answer choices we can just like approximate it when it's equal to 2. So when x is equal to 2, then we have the left hand side be 1, but the right hand side be 2 to the 1 minus square root 2, which is less than 1. right? So the right hand side, when x is equal to 2, then the left hand side is equal to 1, while the right hand side is equal to minus square root of 2. Which is less than 1. Well, why is that less than 1? It is because we have 2 to the 1 minus square root of 2's power is equal to 1 over 2 to the square root of 2 minus 1's power, which the bottom cannot be less than 1, yielding the fraction is greater than 1. No, yielding fraction is less than 1. So the second intersection and as you can see, the derivative thing, as x goes larger, then the derivative of the right hand side would always be greater and greater, but the left side will always be less and less, because when x is getting greater, then 1 over x is going down. So therefore, we know that there are only 2 intersections, which yields an answer between 2 plus square root of 2 and 4 plus square root of 2. And this lies between 2 and giving the answer of D. So the answer should be D for this problem. Thank you for watching. Hope you enjoy, and if you find any interesting problem, don't forget to leave it in the comment section so that we can go over it next time.